You already know that u-Substitution can solve a lot of integrals, but sometimes it completely fails. We find ourselves in this exact situation if we change just a tiny part of this integral. How do we integrate if we remove the exponent of 2 from the e to the x to the power of 2? Now, we can't use u-Substitution. If you try it, you'll just end up going in circles. So, for this integral, we'll have to use another technique called integration by parts. Before we start defining things, remember that an integral is essentially the inverse of the derivative. If you know a function and its derivative, you can set up an integral. Just switch the sides. Integration by parts is the reverse of the product rule. As a refresher, the product rule is the derivative of the product of two functions. That's the derivative of the first function times the second function plus the first function times the derivative of the second function. On the right, let's rewrite the two derivative operators using Leibniz notation, du over dx and dv over dx. And since we know both u and v are functions of x, let's also simplify their notations to just the function names. Now, let's take the integral of both sides to find the reverse product rule. According to the fundamental theorem of calculus, the left simplifies to just u times v. And in the first integral on the right, notice that we have du over dx times dx. For the sake of intuition, we can treat the derivative like a fraction. The dx's behave like they will cancel, leaving us with just du. Similarly, the last integral can be simplified to the integral of u times dv. And finally, let's move the first integral to the other side by subtracting. And now, if we flip the two sides, we have the form for integration by parts. Awesome. So, how is this useful? As an example, let's examine the integral we had earlier, the one that u-Substitution failed to solve. You may have guessed that we are going to use integration by parts, and needless to say, we are trying to find what this integral equals. Using integration by parts, we need to find the u and the dv in this integral. How do we do that? Well, our integral has two functions, x and e to the power of x. One of these will be set to u, and the other will be paired with the dx to become dv. But we're multiplying, so we might have picked e to the x as u and x dx as dv. The only problem is that u and dv must be picked correctly, or else it won't work. You'll find out why later in the video. Now, there's also a trick that helps us to decide what to pick for u, but for now, let's go ahead and integrate the first option by setting u to x and dv to e to the power of x dx. So, we have u and dv. To fill out the formula, we still need v and du. Okay, we know that u is x, so to find du, we take the derivative of u with respect to x. That's just the derivative of x, which we can differentiate using the power rule. That's 1. So du is equal to dx. We also know what dv is, e to the power of x dx. dv is the derivative of v with respect to x. So v is the antiderivative of e to the x, which is e to the x. Now that we have these four terms, we can assemble the second half of the equation based on the integration by parts blueprint. U is x, v is e to the x, we need that twice, and du is dx. So this is what we're working with. Notice that integration by parts gave us another integral, the integral of e to the x dx. We know the derivative of e to the x is e to the x, and of course the derivative won't change if we add an arbitrary constant to the function. So if we integrate, we find that the integral of e to the x dx is e to the x plus a constant, c. Now our answer doesn't have an integral, and it's fully simplified. Awesome. Recall earlier that we had two options for u. We solved the integral by setting u to x, but what would have happened if we set u to e to the x? This won't work, and I'll go through the pain to show you why, so you won't have to. To use integration by parts, we need to know u, du, v, and dv. We know u and dv. Du is the derivative of u with respect to x. That's e to the x dx. And knowing that dv is x dx, we can use the reverse power rule to find v. Add 1 to the exponent and divide by the new exponent. Okay, now we set up the variables based off our formula. U is e to the x, v is x to the power of 2 over 2, and du is e to the x dx. At this point, you may see the issue. While we were able to find v and du, now we have to deal with the nasty integral on the right. Not fun. And if you play it out using integration by parts, you'll just end up with what we had before. As you can tell, the power and usefulness of integration by parts relies heavily on finding the best u and dv. There is a trick that can help us decide what to use for u. To find out what it is and how to use it, check out this video. But before you do, make sure to subscribe. I love making these videos, but scripts, voice recordings, animations, and edits take a lot of time. So if you like this kind of content, consider dropping a like and sharing this with friends. Thank you for watching.